Homework number 21. The first question asks you about a sequence of transformations, and a sequence means more than one. We're applying these transformations to an equilateral triangle. If we look at the transformations that are being performed, translation, reflection, and rotation, they are all rigid motions. And a rigid motion is always congruent. That means all of the angles will be the same, and all of the side lengths will be the same. So if you start as an equilateral triangle, you're going to end as an equilateral triangle. So the first option is, it must be an equilateral. That's true. It has to have the same side lengths. That's true, as the original triangle. The second option says, it must be equilateral. That's true. But the side lengths may differ. That is not true. It may be scalene. That is not true. You can't change your type of shape. It may be an obtuse triangle. That can't be true. You can't change your shape. So the answer is it stays an equilateral triangle and all of its sides and angles are the same. Numbers 2 through 5 ask you to perform a transformation using a mathematical rule. So for the first one, we're going to take this point, -3, 2, and we're going to reflect it over the y-axis. And when you reflect over the y-axis, your point will change the opposite sign. So if you reflect over y, you change the sign of x. So that means our answer here will be a prime, that's the new point, and it will be +3, +2. Question number 2 asks you to take that same point, -3, 2, and perform a reflection over the x-axis. Well, when you reflect over the x-axis, you change the opposite sign. So we're going to change the sign of the second value, which is y, and our new point, b prime, will be -3, -2. Question number 4 asks you to transform that same point, -3, 2, but this time we're going to perform a translation. And they want us to go 5 to the right, which affects the x value. So we're going to add 5 to our x value. And then we're going to go 3 down, which changes our y value. And so we're going to perform these mathematical operations onto the coordinate points we already have. So -3 plus 5 will give me a +2, and 2 minus 3 will give me a -1. That means that for question 4, C prime will be located at 2, -1. And the last question asks us to perform a translation again, but be careful. Even though we're starting with this same point, you have to read carefully the order of the transformations. 2 up is a change to the y-axis, and 4 left is a change to the x-axis. So our new point will be -7, 4. So D prime will be -7, 4. Question number 6, again, asks us about a sequence of transformations. They want to know what we could do in order to take figure P, which is here in red, and get it onto figure Q, which is here in blue. So if we take a translation, that means we're going to slide the object and it will be facing the same direction, which is not what happened here. So A is not possible. If we reflect across the y-axis, then instead of being 2 units to the left, we will be 2 units to the right. So our shape will look like this. If we reflect over the y-axis, we will be in that green position. And now if I shift it 3 units down, it's going to be pointing the wrong way. So that means that option B cannot be correct. Now if I rotate 180 degrees, that means I'm going to move 2 quadrants, whether I go counterclockwise, 1, 2, or whether I go clockwise, 1, 2. Either way, I'm going to end up in the 4th quadrant. Let's take a corner point here, -2, 3, And let's take its corresponding corner point here to -3 and see if that rule applies. So if we start at -2, 3, and we end at 2, -3, and we're following the 180-degree transformation rule, which is that everybody changes signs, this appears to be true. So a rotation of 180 degrees about the origin is the sequence that happened. Number 7. Write a linear equation to represent the following situation. Jenny wants to rent a truck that charges $25 initially plus 10 cents per mile. This right here is the rate of change. So an equation in a linear function takes the form of y equals mx plus b. So we need to know the rate of change, which is 0.10. That's the number that goes with x. And then we need to know any initial or starting values, and that's where the 25 goes. The next question asks us which graph is not a linear function. Well, a linear function is anything that makes a line. B is a line, C is a straight line, D is a straight line, so that means that A is non-linear. Question number 9 asks us to rearrange each sentence so that it's in slope-intercept form. That means y is by itself and the x and the constant are on the other side. So for number 9, I simply need to use an inverse operation to remove the 8x from the left side and make it appear on the right side. Now the good news is it doesn't matter who you write first. You can write the 9 first, giving you 9 plus 8x, or you can write 8x first, giving you 8x plus 9. Both are correct. Number 2 requires us to do the similar move, but this time we'll use subtraction. Again, we've isolated our letter y, and it doesn't matter which term you write first. So this time, I'll write the 7 first. That is in slope-intercept form, because the y is by itself, which is the goal. For question number 11, I don't have a constant or a second term, I just have a coefficient. And you clear a coefficient by using the division property of equality, giving us y equals 3x minus 4. The last one also has a y that's almost by itself. Even though it's on the right-hand side, it doesn't matter. If I can just divide by this coefficient of -2, then I can get that y all alone. Now watch your signs here. 3 divided by -2 cannot be performed with a whole number answer, so we're going to leave it in fraction form. And 4 divided by -2 gives us also a -2. Question numbers 13 and 14 ask us to solve the equation. In number 13, I'm going to subtract 3/5 x from both sides. Even though I typically like my x's on the left, I think I'd like to keep them positive, and since these have like denominators, it will be an easy math move. So that leaves me -15 on the left, 3/5 x on the right, and plus 12. Now I'm going to subtract 12 from both sides, giving me -27 equals 3/5 x. And instead of dividing by a fraction, right? Instead of dividing by a fraction, I'm going to perform that actual operation. We don't divide by fractions, we multiply by the reciprocal, right? We don't divide by fractions. So 3 divided by 3 and 5 divided by 5 give us this beautiful 1x, or just a plain x. Over here, 5 times -27 divided by 3. Use a calculator if you need to. I'm going to do the division first, and then now I'll times by 5 second. So that gives me -45. Question number 14 requires you to do some distributing. So I'm going to get 18 minus 12x on the left. And over here on the right-hand side, after I distribute, I'm going to get -12x plus 18. You'll notice we have matching variable terms. We have a -12x on the left, a -12x on the right. So we might be able to make a conclusion here that if you have matching variable terms and matching constants, then you have infinite solutions. And if you didn't know that, then you could do a little math here. Minus 18 on both sides. And they both become 0, and then maybe now you're noticing it. We've got the same thing on the left and right. But even if you didn't, maybe you added 12x to both sides and realized that they both became zeros, and now you're recognizing that's a true statement. So it's infinite solutions. Numbers 15, 16, and 17 ask you to find the rate of change. When you're given 2 points, you use this formula to help you find that value. It's called the change in y divided by the change in x, or the slope formula. So don't forget to label your points. This is the x1 and y1, and this one here is the x2 and the y2. Don't forget that your formula has a subtraction in the fraction, and then each value brings its own sign to the correct position. So y2 is 4, y1 is 3, so here's the math in the numerator, and then x2, which is 6, minus x1, which is 2. 4 minus 3 is 1, 6 minus 2 is 4, and we've completed the first problem. All right, I'm going to start my subtraction fraction here for the next question. So y2 minus y1 over x2 minus x1. Notice I have some double negatives here. That can happen sometimes. And so when I use my calculator or my mental math, I get 6 minus 2 is 4, and negative 3 plus 1 is negative 2, and 4 divided by negative 2 is just negative 2 with no denominator. All right, last problem, subtraction fraction. y2 minus y1 over x2 minus x1. It looks like I'm going to get a negative 7 over a negative 1, which gives me a positive 7. Questions 18 and 19 again ask you to solve the equation. So I'm going to do a little distributing on the right-hand side here. Get negative 41 equals negative 18x plus, that's going to be a negative actually, negative 2/5 times 60. Use a calculator if you need to. It's going to give me a negative 24. Now I've got 2 like terms here on the right-hand side, so I'm going to simplify that. So I'm going to get negative 17x minus 24. I'm going to add 24 to both sides. And that gives me a negative 17x on the left. And I'm going to get a negative 17 also on this side here. Oops, I said the negative 17x on the right. And when I divide by negative 17, I get positive 1. Last one, 16n plus 10 minus 3. On the right-hand side, we're going to get 16n minus 4 plus 11. Let's combine some like terms here and here. Looks like I've got 16n plus 7, and on the right I've got 16n plus 7. Do you see it? Do you see the matching variable terms? Do you see the matching constants? Infinite solutions. And that concludes homework number 21.